Hello everyone. So today I'm going to be helping you all solve a very important question that is actually a JEE PYQ. So it was asked in the JEE Mains 2024 9th April shift 1. So this is a question on organic chemistry which requires an understanding of the reaction mechanisms. So for the upcoming JEE examinations in January, you must all learn the mechanisms of the important reactions in organic chemistry, because questions may be asked based on the mechanisms too, not just the reagents. So let's get started. So this is a very tricky question. You need to have a thorough understanding of many important concepts to answer this. So let's get started with it. So first we can see that they have given us a cyclobutane which has one chlorine and one bromine atom attached to it, and then we have the reagent NaEt2O. So first we need to understand what is Et2O. So Et2O is nothing but diethyl ether, that is this. So Et stands for ethyl. So there are two ethyl groups attached to a single bonded oxygen. So it is diethyl ether. So sometimes the structure may not be given and you may be asked to solve the question based on these abbreviations like Et2O, D2O and things like that. So you need to make out what that means. This is diethyl ether. So whenever we think of sodium with diethyl ether, a reaction comes into our mind, that is the Woods reaction, right? So the Woods reaction comes to our mind. So that means this has something to do with Woods reaction, because we have an alkyl halide. We have a chlorine and a bromine atom attached to carbon. So it is an alkyl halide having two halogens. And then we have given this reagent. So Woods reaction should come to our mind naturally. Now let's see. So then A is a product, and A, on treating with COF2, we are getting C. So COF2 is the reagent for Schwarz reaction. So Schwarz reaction, we all remember, it is a fluorination reaction where an alkyl halide is converted to an alkyl fluoride, okay, by the use of a fluorinating reagent like the fluoride of silver, tin or any such heavy metal that is used. So that means A has to be a haloalkane, because only haloalkanes will undergo Schwarz reaction with COF2 to give an alkyl fluoride. So A must be an haloalkane. But the problem is that Woods reaction, the product is an alkane, not a haloalkane. So one might assume that this compound ClBr, when we are treating it with sodium, so sodium will take up the chlorine and take up the bromine, and then we will get an alkane. First we will get a free radical like this, because sodium will take both the chlorine and both the bromine, and Woods reaction is a free radical reaction. So let me write Woods reaction. It is a free radical reaction, we know, where the free radical is the intermediate, and so one might assume that this is going to happen, that two free radicals will be formed over here, and then whenever two free radicals are formed, it might join to form this compound, that is it's a cycloalkane. It has two 3-membered rings and one 4-membered ring. So one might assume that this is the product, and this is how it should be actually. But it depends on the question too. You cannot just do anything you want. You have to adhere to the question, what the examiner is trying to ask you. So A should be this, but A is treated with COF2 to form C, right? And C is an alkyl fluoride, and A has to go Schwarz reaction. So A can never be an alkane, because alkanes do not undergo Schwarz reaction, and alkyl halide does. So A must be an alkyl halide. So we need to think about an alternative pathway for this reaction, and there is an alternative pathway for this reaction. So the alternative pathway is that A has to be an alkyl halide, either an alkyl chloride or an alkyl bromide. It has to be an alkyl halide. So any one of the bonds have to break, between carbon chlorine bond or the carbon bromine bond. Any one bond has to break, because one halogen atom must be there. Okay, so between the carbon chlorine bond and the carbon bromine bond, one has to break, and we have to understand which one is the weaker bond. So we know that in the periodic table, the halogen group is like this: chlorine, 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 bromine, then iodine, right? And if we consider the bonds of carbon fluorine, carbon chlorine, carbon bromine, and carbon iodine, then the weakest bond will be carbon iodine and the strongest bond will be carbon fluorine, because fluorine, it has a 2p orbital, chlorine 3p orbital, right? 2, 3, 4, 5, and carbon is a 2p orbital. So the carbon fluorine bond is a 2p 2p overlap, whereas a carbon fluorine bond is a 2p 3p overlap, and then we have 4p 5p and so on. So a 2p 2p overlap, since the orbitals are of the same kind, then the bond generated when two similar orbitals overlap is more stable than a bond which has a higher energy difference. For instance, the 2p 2p bond is more stable because it has a less energy difference than a 2p 3p bond. So definitely the carbon fluorine bond is stronger than a carbon fluorine bond, which is stronger than a carbon bromine bond, which is stronger than a carbon iodine bond. So obviously between the carbon fluorine and the carbon bromine bond should break because it is weaker than the carbon fluorine bond. So if this bond breaks, that is, the sodium will take up the Br to form NaBr, and we will be left with this. So this is a free radical. Now in another molecule the same thing may happen, and we get another free radical with a chlorine. Now these two free radicals, they will now join, because it has not been mentioned that there is 1 mole over here. We can take any moles we can. So this is also a probable product. We cannot neglect this. So this will form, these two free radicals will join to form a single bond, and we will get this. Now this has a chlorine atom, this has two chlorine atoms, so it can easily undergo Schwarz reaction, right? So the product A is this. Now this will undergo Schwarz reaction with COF2, and we know that what happens in Schwarz reaction, the chlorine atoms will be replaced by fluorine atoms. So the chlorine atoms have been replaced by the fluorine atoms. So this is the product C and this is the product A. So in the question you were asked an MCQ. So this was an MCQ question, obviously it's a JEE Mains PYQ. So the structures of this A, B and C were asked, okay? And if you do not know the structure of A, you won't be able to know the structure of C or of B. So now anyways we know the structure of A and C now. So we can easily predict the structure of B too. Now this A, when treated with magnesium, again in presence of diethyl ether, and then followed by D2O, will give you B. Alright, so A, we know this is A, this structure is A, this chlorine. So now we have to treat this A with magnesium in Et2O. So we know that whenever an alkyl chloride is treated with magnesium in ether, then the product is a Grignard reagent, alkyl magnesium halide, right? So what happens is that this RCl in Mg ether, this will give you RMgCl, that is, the negative charge will be on carbon or the alkyl group. So this A, when we are treating it with magnesium in dry ether, so these chlorines should be replaced by the magnesium, and there will be a negative charge on either of these two carbons. So the product will be something like this: negative charge over here, negative charge over here, magnesium chloride, and then we have magnesium and chlorine. Okay, so this is the Grignard reagent. So this is an application of Grignard reagent. Okay. Now we are treating with number 2, that is D2O. Now D2O, we all know what is D2O. So D2O is basically, so deuterium, which is D, is basically the heavier isotope of hydrogen, and D2O is heavy water. We all know that. So H2O is the normal water, D2O is the heavy water, because D is the heavier isotope of hydrogen, that is deuterium, and D2O is the heavy water. Now we know that any Grignard reagent, when reacts with water, it will always give an alkene. Why is that so? Because RMgX plus water. So water has an acidic hydrogen, and it is very important to note that whenever there is an acidic hydrogen, then the Grignard reagent will behave as a base, not as a nucleophile, and it will abstract the acidic hydrogen of that particular compound to form an alkane. So that is very important in case of water, in case of alcohols, in case of carboxylic acids, there is an acidic hydrogen. So the Grignard reagent, the R minus of the Grignard reagent, will abstract that acidic hydrogen, and it will always give an alkane. So we get RH plus an addition product, which I'm not writing because it's not important for this question. So similarly, D2O is also like water only. D is also acidic. It's not hydrogen, it's acidic deuterium. So the examiner, he or she wants to test your concept of a mechanism, that whether you know that this particular Grignard reagent, in the presence of a compound having acidic hydrogen, whether it will abstract an acidic hydrogen or not. So the examiner has just replaced water with D2O, and you should not get confused at all. You just follow the normal mechanism and answer the question. So now what is going to happen is that we know that this minus will abstract this acidic deuterium of heavy water, and it will give a compound like this, having deuterium instead of hydrogen, because we have taken D2O. We know that this Grignard reagent with water gives RH, so this also with D2O will give RD. So this is the structure of B. So we know the structures, the three structures. This is the structure of A, this is the structure of C, this is the structure of B. So the interesting thing is that in the same question you were asked three different mechanisms, three different logics which you had to apply at that instant. So for these, the practicing of PYQs is very important, and understanding the mechanisms and not just mugging up the reactions or the reagents. That is also very important, because mugging up the reagents will not give you the answer to this question. You need to know the mechanism, know the pathway, the different pathways, why this compound is not forming and this compound is forming. You have to know that, because this can also form, but according to the question, if this is formed, then C won't be obtained, because alkanes do not give Schwarz reaction. So this must be an alkyl halide. So that's why you have to consider an alternative pathway. So yeah, that is an important thing, and this is the answer to this question. So A is this, C is this, and B is this. So thank you for watching. If you like this video, if you think this video helped you, do leave a like and subscribe to my channel, because I will be posting more such PYQs, the explanations, the questions for your help. And JEE is in 2 months, so you need to start practicing as many PYQs you can. So thank you for watching. Goodbye. I will see you in the next video.